Now, without further ado, let me introduce you to Jim Barton, not to be confused with Jim Burton. Jim Barton is a field engineer for Solo.io, whose enterprise software career spans 30 years. He has enjoyed roles as project engineer, sales and consulting engineer, product development manager, and executive leader of tech startups. Prior to Solo, he spent a decade architecting, building, and operating systems based on enterprise open source technologies at the likes of Red Hat, Amazon, and Zappos. After 2 years of COVID-driven, Zoom-encrusted isolation, Jim especially enjoys sharing with and learning from three-dimensional people at technical conferences around the world. Jim, thank you so much for being here. It's a pleasure to have you. The stage is all yours.
Thank you. Thank you. Can I just say, I speak at a lot of technology conferences, and when you see that you've drawn the Friday afternoon 3:40 p.m. slot, you think, oh no, there'll be 2 people there, right? And so, can I say, if any of you are looking for a job, I can tell you're dedicated. So come speak to me afterward. But really, I really do. I appreciate you being here. This is, as was said in the introduction, this is going to be an interactive session. So if you have a laptop, I encourage you to get that out, spin it up, and feel free to follow along. Now, everything that we'll be doing will be up here on the screen, so you'll be able to follow along even if you don't have a device with you. But if you have a laptop, I encourage you to get a little extra out of the experience and join us. Join us in that way. If you have a smartphone, I don't think that's going to be, I don't think that will give you that great of an experience. But the laptop would be ideal. So this is, as the title suggests, this is an interactive tutorial. So I do invite you to follow along. So this is getting started with Istio Ambient Mesh, an interactive tutorial. I gave a talk yesterday where we talked a little bit about Istio Ambient Mesh, what's going on there, a little bit of the genesis behind it, and we'll go over some of that material today, but the vast majority of our time is going to be spent in the interactive part of this, really walking through it, giving you an experience in setting that up, in establishing some policies that manage traffic in a network of microservices, that provide security among that within that service network, and also just a bit about basic observability tools that are available there as well. Okay, so that's where we are headed today. Again, I am Jim Barton. I'm a field engineer in the U.S. with North America. With me today is Christian Fekete. Christian is there's really 2 good things you need to know about him. One is he's local here in Budapest, so if you're local, you can speak to him in Hungarian. Don't try that with me. And second, he's smarter than I am. So if you are going through the exercises and you have an issue, feel free to raise your hand. Christian will be. We can either, if it's something we can't resolve interactively here, Christian will be happy to come around and help you get on track. So very glad to have you here with us today. Okay, so I am going to go through some basic material just to set the stage for what we're going to do here, but I do encourage if you have your laptop and you want to follow along, go to this website, academy.solo.io. Okay, academy.solo.io. I'll leave that up there for a second. This is what it should look like. So you should see an interface that looks something like this. If you scroll down very, very high in the list of on-demand courses, there's something right here called Get Started with Istio Ambient Mesh. Click through that. If you have never been on the Solo Academy before, well, first, shame on you. No, it's okay. It's fine if you haven't been on Solo Academy before. But if you haven't been on Solo Academy before, it will prompt you to register, and so you'll need to take just a minute to do that. Once you get through that process, then you will end up at a interface that looks something like this. Okay, and so you will have to click through these first two elements here, the introduction and the demo piece. Please don't turn the sound on and watch the demo out loud. We'll actually be going through it in person, but I believe you do have to click through it before you can get to the third step, which is what we're going to be focused on today, which is the hands-on lab. Okay. So once you register, once you get through click through those first two steps, then you should be able to activate the hands-on lab. And at that point, you should see an interface that looks something like this, okay? And when you see that, you will see a blue button here somewhere that says Start Track. When you press the Start Track button, what that's going to do is it's going to begin the process of spinning up an environment that's just for you. So we're all going to be operating in our own sandboxed environments. This afternoon, we're going to spin up basically a 4-node kind cluster to simulate or to be our deployment environment, and then we're going to do some Istio deployments and specifically some ambient work and policy definition and that sort of thing within that context. So when you get to this point, feel free to hit the Start Track button. Then you'll see an interface like this. You'll notice an attractive little countdown timer here that tells you approximately how much time is left before your environment is ready. So I'm going to go back to the first tab here. Again, if you walked in late, the website to go to if you'd like to follow along on your laptop is academy.solo.io. academy.solo.io, and go to the Get Started with Istio Ambient Mesh workshop here. Okay, so while you all are busily doing that, let me go through just some material here to level set where we are. Oh, let me say this as well. The nice thing is we have we have a nice long bit of time here, so we have almost an hour or 50 minutes left. So that's plenty of time to work through this workshop. If you have questions, feel free to raise your hand. We'll be happy to take those. We have a handheld mic, right, that we can, if there are questions that come up, I think. Okay, very good. So feel free to ask questions. At the end of the session, and there should be time to complete this right here in this room if you choose to, there is a certification completely free that Solo offers. It's actually part of that same workflow that you're in there with Solo Academy. So you can go through that exam. I think it's, I don't know, 10, 12, 15 questions, something like that. You get 80% of them right. You get a little Credly issued badge that you can put on your LinkedIn profile, like, hey, I have foundational skills in Istio Ambient Mesh. So if that's something that's interesting to you, we can support you on that right here in this room. There are also a number of other open source technologies that are foundational to what Solo does, things like Envoy, basic Istio, eBPF, which actually Christian is one of our experts in eBPF, Cilium technology, a whole lot of foundational open source technologies that Solo uses as a foundation to build its product suite and offer services on. And so you can actually go find courses and get certifications in all of those, and some of them, particularly with Istio, all the way up to kind of advanced and expert sorts of certifications. Okay, so we invite you to be a part of that. Again, it's absolutely 100% free for you to participate. So if we talk about Istio for just a minute, Istio has been around since 2017 now, and Istio is all about recognizing what's going on in the microservice landscape, right? So, we used to have a very simple world where we had a relatively small number of large monolithic applications. We're migrating toward a world where now that's less the case than it used to be, right? Now we have, rather than a small number of large software boxes, we now have a large number of much smaller microservice boxes. And so we need to be able to have ways we can connect those together effectively, establish traffic policies, that sort of thing. We need to be able to secure those, both from the outside world, services coming into the application network, as well as securing the services within the network, right? So we need to be able to establish things like MTLS communication to ensure that all of the traffic is encrypted and so forth, as well as observability, right? If we are moving toward a world with a larger number of smaller networked services, we need to be able to observe what's going on inside that application network, right? And so Istio is all about providing those three pillars in a microservice cloud-native context: connect, secure, and observe, and doing all of that without modifying the underlying service code, which is really, really important. Okay, so since 2017, Istio has become now by far really the most popular service mesh project. It was originally created by Google. It was contributed to the CNCF, Cloud Native Computing Foundation, early last year. And then as a result of the experience that we gained with customer environments, we began realizing there were some things that we could improve about the architecture of the data plane. So how your requests are actually processed through your application network. And so as a result of those insights and from that experience from the thousands of production customers that are out there, Istio Ambient Mesh was launched last year as a collaboration between Google and Solo.io in September of 2022. And we anticipate that it's actually been merged into the main branch of Istio at this point, and you'll actually be, you'll be using it today. So, let's, one other milestone that is coming up pretty soon. If you're familiar with the CNCF's process for how it manages projects, so initially projects are accepted in a sandbox state, right? Which is, hey, this is interesting, but it's really not necessarily been proven out and recommended for large-scale production use. And then along the way, as projects gain experience, gain users, gain contributors, then they move toward eventually becoming a graduated project. So, for example, projects like Envoy Proxy that, very, very foundational part of cloud-native architectures. Envoy Proxy is a graduated CNCF project, for example. And also, Istio is very close to achieving that status as well, which I think speaks a lot to its maturity and its adoption and the size of the community. There are hundreds of organizations now that are active contributors to the Istio project. So at any rate, this proposal was actually made a few weeks ago, and we're in the middle of a public comment period right now, and what we anticipate is in the next few weeks to next few months, we expect Istio to move into a graduated state at CNCF. Again, just speaking to its maturity and production readiness. Okay, that's enough of that. So, Istio Ambient Mesh, as I said before, is a collaboration between Solo and Google that was contributed to the community last year, and it basically defines a new sidecar-less data plane. What do I mean by that? So, if you're familiar with Istio architecture, one of the foundational elements of the Istio architecture is the fact that you have workloads that need to talk to each other, and those workloads, a lot of those cross-cutting concerns, the connect, secure, observe sorts of cross-cutting concerns, are implemented using a sidecar. So an Envoy sidecar is injected into those workloads, and so the workloads, the services, don't actually communicate with each other directly. What they do is they communicate with the sidecar. The sidecar does things like applies policy, establishes secure communications across nodes, that sort of thing, and then does that work on behalf of the workload as managed by declarative policies that you can establish. So this is a new way of envisioning that the data plane architecture of Istio that actually makes it quite a bit simpler. It's much more efficient to operate. Cost reductions, simplified operations, improved performance. We'll talk about some of the details of those in just a minute. But this comes out of the experience that we've gained with the community over the last 6 years. Okay, so to visualize what's going on here, we'll take a couple of steps at this from a visualization standpoint. But The traditional Istio architecture looks like the diagram on the left. So the light blue the light blue boxes are the service workloads, the application workloads, and for each of those that need to participate in the service mesh, there is an Envoy proxy that's injected with each one of those workloads. So you have 30 separate microservice instances, you have 30 Envoy proxies that are deployed, and those are injected. The Envoy proxy are injected into the same pod with the workload, and then mediates all of the communication between workloads. What we're doing with Istio Ambient Mesh is both slimming down the footprint of Istio as well as enhancing the security profile by taking those proxies and sort of absorbing those, extracting those from the deployment pods and putting those actually in two forms. And we'll have a slide that speaks to that, but basically we're greatly reducing the deployment footprint, the cost, and so forth. So let's drill into that just a little bit, and then we will get into the actual workshop. Okay. So the way a request flow typically works in traditional Istio is you have a workload on the left that needs to talk to one of the workloads on the right. The communication goes through its attached proxy over the network to the other workload through its proxy, and basically policies can be applied at either end of that connection. So with ambient mode, and by the way, these two can interoperate just fine. We'll actually do that as the final part of the exercise today. So in ambient mode, what happens is there are actually two types of proxies that are in play now. There's one that's called a zero trust tunnel, or a Z tunnel for short. That is a layer 4 only proxy that exists on a per node basis. It is not it is not injected directly into the workload. It's actually part of the infrastructure that lives on the node. We'll show you that. And so it's able to apply all of the layer 4 level policies. For example, I want to allow this service identity to speak to this service identity, and I want the communication to be encrypted, that sort of level. And then if you need higher level layer 7 policies associated with those workloads, for example, things like I would like to inject a 5-second delay into this request path, or I would like to be able to allow get operations on this for this against this endpoint on this workload, but not put or post or delete operations. Then you need something that's going to implement layer 7 services, and that's called a waypoint proxy, and you see that depicted here. So in cases where you need those layer 7 services, you will deploy a waypoint proxy, and we'll actually walk through an example of doing that today. So basically, two new elements of this data plane architecture in Istio: the Z tunnel or layer 4 proxy and the waypoint or layer 7 proxy, neither of which are directly injected sidecars into the workload. So let's talk about. So here is what the flow looks like. So let's say application A needs to talk to application D. Those are on different nodes. So what's going to happen? The request goes out. There is a CNI layer, you're going to see that today as well, that's going to set up the traffic redirection on the local nodes to ensure that all traffic that comes from application A in this instance is redirected to the Z tunnel on that node. And so that traffic is going to be directed there. There's going to be an if there is a layer 7 policy, there will also be a waypoint that's in the path here, and there'll be a secure connection that's established between those. That waypoint will talk to the Z tunnel on the target, the destination node, and then it will in turn talk to the application service itself. So the idea here is that layer 4 policies can be applied strictly with the Z tunnels. If you need layer 7 policies, that requires the introduction of the waypoint. Okay? Any questions so far? Good? All right, in the back. Yep. So let me skip forward a bit here. So yeah, one of the things that we've done with so the question is about the Z tunnel and whether it uses overlay networking techniques. So basically, what happens is we've established a protocol here called HBone, HTTP based overlay network encapsulation that's actually used to manage the connection between the nodes. It's a TCP, basically TCP over HTTP tunneling mechanism. And so, this is really important for a couple of reasons. There are some sort of edge cases that aren't managed well by Istio today because it uses it just upgrades standard HTTP connections. So, for example, things like server-first protocols. So, if you're using a database like MySQL, MySQL employs a server-first protocol, and that creates issues in a traditional Istio environment. So this overlay protocol actually works with in that sort of use case a lot better than the traditional. There are a couple of other use cases as well, but that's probably the one I've personally heard the most as being valuable. So yeah, there's definitely some overlay concepts here. So just to go back to this, and then we're gonna hop straight into the exercises. So we're still using, if you're familiar with the Istio architecture, the control plane for Istio is called Istio-D. So Istio-D, whether you're talking about the traditional proxy-based, sidecar-based architecture, or the newer ambient sidecarless architecture, Istio-D is the control plane that manages each of those. You simply specify the policies that you want using the Istio API, Istio custom resources. Those are managed by the Istio-D control plane. The control plane then translates those into configuration for whatever data plane architecture you have. So it can still translate that for Envoy configuration for sidecar proxies, or for configuration of the Z tunnels or waypoint proxies as well. So basically, the API is essentially unchanged. It's the same API as before. It's just the way that's implemented in the data plane is going to be slightly different and more efficient, easier to operate, that sort of thing. Okay. Thank you for that question. All right, so let's get started here. If you have your laptop, so you definitely, I've been running my mouth for long enough now that you all should be, at this point, you should have a green start button at the bottom right of your screen. So go ahead and click through that, and that's going to activate the Instruqt environment for us. Now, if you haven't used Instruqt before, and if you do a lot of complex, let's say, demonstrations or educational workshops where you need to have a lot of people and each person has their own complex environment, this is a really great environment. So what happens is each one of us have our own environment that we can work in now. So you have your kube cluster, I have my kube cluster, and we're not going to step on each other. So that's part of this, and what we're going to do now. So we basically have a Linux shell on the left side. We have commentary and basically command scripts to enter on the right side. So the idea is we're trying to make this as foolproof as possible, so Christian doesn't spend his time running around trying to solve technical problems. So what I want you to do is just, if you look over here, anytime you see one of these dark boxes, there'll be an icon over here on the right. You click on that, that's going to copy whatever that command block is into your copy-paste buffer, and then you can paste that over here in the Linux shell, and boom, there you go, okay? So that will hopefully make this run as smoothly as possible. So the first thing we're going to do, we're going to deploy a 4-node kind cluster. So click in this box here, which is basically just a deployment script. There's absolutely nothing, Istio specific in there at all. This is just a script that basically activates kind, spins up 4 nodes in a cluster, and there's really nothing special about that we need to discuss. But this will take a minute or two to spin up. So while we're waiting on that, let me just preview what's coming as we walk through this first exercise. So one of the things I really like about this exercise, besides the fact that it's interactive, is the fact that we're actually building this from scratch. So you actually get the feel of what it's like to work with this from scratch. So we're going to run a little check script in just a minute to make sure our nodes spun up correctly. And then what we're going to do, we're going to download the latest Istio version. We are going to install that using the ambient profile here. So Istio comes with a number of profiles available for demo, for basically almost minimal configuration, so that you can configure for your own, say, a production environment, that sort of thing. But there's specifically to help evaluate ambient. There's a profile out there that specifically spins up just the components that are necessary to run in ambient mode. So we'll be using that profile today, and then we'll be installing some services that we'll use throughout this exercise to actually sort of test out and show the capabilities of Ambient Mesh. And finally, we'll just use some standard Istio APIs to expose these services to the outside world and test them out. Okay. So hopefully we are just about done here with the kind cluster. So if you take a look, if you look at the nodes that are available here, we should have 4 nodes. We've kind of designated one. Let me see if I can make this a little bigger for you. Okay. Hopefully that's better for you in the back there, and for people watching. Oh, that's not good. All right, that's better. Okay. Whew. I was going to say I'm sweating, but I'm sweating anyway. So. Okay, I didn't. Yeah, we lost the feed there. This commercial brought to you by the beta version of our HDMI adapter. Oh, we have another one. Okay. This is actually the 4th HDMI adapter we've tried now. Yeah, we'll see. Maybe that one just needed a break. Okay, it detected there is a display there. All right. Hey, we have a winner. Whew, yeah. All right. Christian, did you remember to offer our ritual sacrifice to the demo gods this morning? Because if you don't do that, then oh no. You didn't, did you? I did. I could try to scale down the resolution. Oh, you have another. All right, we have a 5th one we can try here. I promise I've done this before. Let's see. Automatic scaled. Default, more space. All right. HDMI number 5. No, but please, go ahead. I'm sorry, could you repeat? You have the mic, yeah. Hey, and it's still up there too.
Good, because at least our viewers are also going to have the chance to.
All right. So what's the advantage of using the H1 protocol instead of like IP or anything else that's already been existing?
Yeah, it's a good question. We really view that, or we hope people will view that, users will view that really as an implementation detail. I'm really not even qualified to speak to the specific differences there. I mean, some of the things I talked about before are the reasons why HBone was created in terms of better supporting server-first protocols and that sort of thing. I don't know, Christian, is there anything you wanna add about that in terms of the protocol itself?
One second.
Speak loudly. Yeah.
Oh, 1 second. Bring the mic for you.
Thanks. So basically, the reason why there's HBone in the picture is that Envoy is using this filtered architecture where you can chain multiple filters right after each other, and you can reach pretty complex use cases where you have multiple filters, and in some cases, these inside the filters will be translated into almost like a request is being sent to the request itself. So based on these edge cases and limitations, it was easier to build the zero trust capabilities based on HBone itself. There are some optimizations inside Envoy and some edge cases and limitations that would be hard to maintain without this new protocol. We actually have a blog post. We also have a solo blog post on this topic about rewriting the Z-Trust tunnel. And there's also a more extensive blog post on the Istio blog, and that goes into more details about these edge cases. You can actually, I think one of those, maybe the Istio ones also has the actual lines of code for these edge cases, so feel free to check those out, and yeah, we can also have a discussion after the talk about these details. Yes, that's the solo one that I mentioned.
Yeah, that's a really interesting blog post. To really understand more of the details of some of the reasons behind ambient mesh and some of the things that are going on there. When we initially created ambient mesh, it was basically done with the layer 4 proxy was just a specialized instance of Envoy. And so what we found was that was pretty difficult. We kind of knew from the outset, but it was pretty difficult to maintain because Envoy is not inherently multi-tenant. And so having a Z-tunnel on a per node basis, sharing multiple workloads, created some pretty complex Envoy configuration, and it really didn't meet our performance goals. And so one of the things we did is rewrote that aspect of it to be just a layer 4 proxy implemented in Rust. And so the memory footprint has just gone to, not to zero, but it's very small, it's very efficient, very fast, but it still uses the same APIs, of course, that Istio's been using for some time. So yeah, thank you for that insight there, Christian. I appreciate that. Yeah, thank you, appreciate it. Great question, by the way. Okay. So, all right, back to our exercise here. So you can see that we have, so after we ran our deployment, everything completed, we also ran this check script here, and we've had plenty of time now, so everything has spun up, so that's all good to go. And now we're actually going to download this Istio release. This is actually the 1.18 release that has the ambient profile, again, part of the main Istio branch. And then we are going to install this using the ambient profile. If you can see there at the bottom of the screen, we've established the ambient profile just to set up the core elements that we need for ambient mesh. So it's going to set up things like let me scroll down here. This is what you're going to see on the screen here as this installation goes through. So of course we have Istio-D. Istio-D is the control plane that's required no matter what mode you're running Istio in. The Ingress gateway, so we're going to use the Istio Ingress gateway to manage traffic that's coming in from the outside into our cluster. we are going to install the Istio CNI. The Istio CNI is going to be responsible for redirecting traffic from the workloads on each node to their local Z-tunnel. So the CNI takes care of that. And then the actual per node Z-tunnels themselves have been installed. So if we take a look at the collection of pods that are out there, you can see actually all of those things that I just described. So there's a single Istio D instance. You can see that here toward the bottom. You can see there is a Z-tunnel running. Remember, we have 4 nodes, so we have a Z-tunnel running on each node. We also have a CNI deployment or a CNI pod running on each node. And then we also have an ingress gateway that's managing traffic coming in from the outside world. So that all looks good to go. Hopefully, if you're following along, you see something similar on your display. Now, we also have CRDs that are associated with the API gateway, or the gateway API. We're going to be using that to establish the waypoint proxy in just a bit. Those are not installed by default with Istio, so we're going to install those CRDs just to make setting up the waypoint proxies a bit easier. And once we have done that, we're actually ready to deploy our application services now. Now, this is a very simple set of application services. Let me give you a picture of what we're going to be doing here. So think of this as, the skeleton of an e-commerce system. So we have a web API, which is where traffic comes through initially. The web API is going to talk at some point to a recommendation engine. The recommendation engine, to make its recommendations in turn, is going to talk to something that tells about your purchase history. And so that's the chain of microservices that we're going to be managing here. Obviously, yours will be more complex than that, most likely. And so that's the sequence we're going to be managing here, the sequence of microservice invocations. And what these services are, you may think, oh, wow, they went out and they built all these services. We actually didn't really build anything. We're using something called the fake service. If you've never used it before and you're just trying to simulate what an application network looks like, the fake service is actually a nice little tool for doing that. Basically, you make a call into the fake service. The fake service is just going to print out some information that says, hey, I'm the fake service, here's my configuration message, and here are the other services that I call. And so what you're going to get here is you'll get a chain of, the web API responds, and it calls the recommendation engine, which in turn calls the purchase history, and you'll see all 3 of those in a kind of in a nested JSON output. Okay, so that's that's our quote-unquote application service for the day. And so let's go ahead and deploy those fake services. So we'll create a namespace called test in our kube cluster to hold that, and then we'll deploy. You can see there are a number of services that we've put out there as we just described. We've also established a couple of services that we'll use as clients in this exercise. We call one of them sleep. We call the other one not sleep for reasons that I don't completely understand, but that's what they're called. And so if we take a look at the pods that have been created, there you go. You can see those are the 5 pods. You can tell, right, there's a single container in each of those pods, so we have not, we're not doing anything, injecting sidecars, anything like that. We just have those pods running in our cluster. Okay, so that's all good. So let's just do it. Let's do a simple test here. Let's exec into one of our pods, and we'll make an HTTP call to our web API, and you can see what this looks like before we really get Istio involved. So as I said, the initial call goes to web API. We get back some, kind of some configuration, start, stop time information, that sort of thing. And then you can see web API makes a series of makes an upstream call to the recommendation engine. The recommendation engine in turn makes an upstream call to purchase history v1. Keep in mind, we're going to do some traffic shifting, and was one of our exercises. So we'll have a purchase history v2 at one point that actually has a slightly different message here, and so we'll be switching between v1 and v2 in one of the later exercises. Okay, so our fake service is working exactly as we expect it to. And now what we want to do is we want to take this web API, and so right now we're just execing into this from inside the cluster. We also want to expose it so we can get to it through the ingress gateway, because obviously we want people to be able to call our web API from outside of our cluster. And so to do that, let's take a look. We have a couple of configuration components here. And this is just, these are standard, this is standard Istio API. I'm really hesitant. I don't want to resize that. The last time I resized that window, bad things happened. So let's work with this. So we're going to establish an Istio gateway. So basically that's just, here's a host and a port we're going to expose to the outside world, and we're going to accept traffic into that. So you can see istioexplain.io is our host. We're going to be listening on port 80, and we're going to then establish a virtual service that selects that gateway, listens on this same host, and then for its traffic, you can see we have a single route defined here. A lot of times in a virtual service like this, you'll have some kind of predicate, like I only want to receive requests that are, say, prefixed with this HTTP path, or maybe, that have this header, that sort of thing. In this case, this is just absolutely as simple as you can get. We're saying any traffic that comes in through that gateway targeted at that host, we're going to route it to the web API service, and that's all there is to it. So it's just a very, very simple virtual service to start with. We'll make it a little more complex as we go through this exercise. So let's go and we will apply the gateway and the virtual service. Okay, so those are out there now. And then we're going to put in an environment variable the gateway's IP address, so that we can call that from outside. And finally, we're going to actually make that call through the gateway, through the virtual service. We're going to invoke this same service, but through the ingress gateway. And when we do that, you will see, not surprisingly, that we get exactly the same results as when we invoked it from a pod inside the cluster, and that's exactly what we want to happen. Now, at this point, we are at the end of the first exercise. We really haven't talked at all so far in this exercise about ambient mesh, a whole lot, but that's about to change. We're going to start applying some policies, and you'll see some things start to happen. In this next exercise, we're going to focus on layer 4 policies, observability, security, that sort of thing, using just the Z-tunnel component. And then in the third exercise, the following exercise, we'll talk about layer 7 policies and how to apply those with ambient mesh. And then finally, we should have time to show you an example where the traditional sidecar mode and the sidecar-less mode of ambient mesh are able to interact seamlessly. So that's our roadmap here. So if you have followed along with me to this point, first of all, I'm very impressed. And second, what I encourage you to do, you see these buttons down here, hit the check button at the bottom. That's going to check your work and make sure, hopefully, that you haven't misconfigured something like I tend to do. And okay, we got a green bar, that's good, and that's going to take us to the second exercise. So we're going to begin now by actually adding some services to ambient mesh. We're going to take a look at some of the layer 4 statistics that are published from the Z-tunnel, and we are going to apply some layer 4 authorization policies. So one of the things that's really nice about ambient mesh that we see in our customer base is there are a lot of people, I don't know how many of you work in maybe heavily regulated industries like telco, maybe in a government agency, financial services, something like that. But a lot of people, when they're getting started, really only care about the security aspects of Istio primarily. Like I have a mandate in the US, for example. In the US, the Biden administration has published an executive order that requires all government agencies to employ best zero trust practices. And one of those practices is encrypting all communications within the service network using MTLS. And so if that's your goal, right, then this is a really effective way to get to that goal. And with Ambient Mesh, you can do that in an incremental way. You don't have to adopt all of the Istio infrastructure. You can simply kind of incrementally adopt just the security aspects, just the Z-tunnel, layer 4 aspects, if you will, without adopting the full suite of features and services. So that's what we're going to be focused on here right now, is just adding in those security-focused components. So to do that, the first thing we will do is we are going to label our namespace. This is the easiest way to get started with identifying certain namespaces as being things we want to participate in the mesh. And so you can see we're going to label this namespace with data plane mode equal ambient. And when we do that, what's going to happen is that's going to automatically cause our CNI layer to kick in, and it's going to redirect traffic on each of those local nodes between the source and target workspaces and the actual Z-tunnel that's running on that node. So you can see that if you take a look at the CNI logs, you actually get a feel for that. I should have shown you the before and after picture. Before, there was nothing about ambient in the CNI logs, trust me. But here you can see there are a number of ambient rules that are being applied. So specifically, you can see things like, hey, now that this namespace has been labeled, I'm adding this pod to ambient, I'm adding this pod to ambient, I'm redirecting traffic from this location to that location, that sort of thing. And so that's what you're seeing in these log messages right here, is that that's the work that the CNI on the CNI daemon set is doing for us. Okay, so basically there's a bunch of commentary that says pretty much what I just said. And so what we're going to get to, again, show you this from a picture standpoint. What's going to happen now is, let's say we have a deployment that looks like this, where we have these separate nodes. We have our client node on one, we have some service nodes on the other one. And so when we're applying just these layer 4 policies, what's going to happen is the policies are going to be served up from the Istio control plane to each of the Z-tunnel components. Note that we don't have there's no proxies injected into the sidecars at all. We simply have this very efficient layer 4 proxy on each machine. The traffic goes to the proxy. There's an H-bone tunnel that's going to be established between these two tunnels. The traffic is going to be sent across and then eventually make it to the target workloads. So that's where we're headed in this exercise. Okay? So also what's happening here is from a security point, we have certificates that are being assigned. So basically the Z-tunnels are going to act by impersonating the client on whose behalf they're acting. So basically the Z-tunnel on the left node there is going to impersonate the client. The Z-tunnel on the right node here, depending on who it's managing traffic for, will impersonate both the web API and the recommendation. And so it can effectively apply policies that tell us things like, I only want recommendation to be called from web API and not from anywhere else. So in other words, establishing a zero trust policy and just allowing kind of least privilege access to just the components that need access. The Z-tunnel is going to effectively manage that as we build up this policy base. Okay, so now what we're going to do is we're actually going to generate some traffic, and we're going to show you that that it is in fact the Z tunnel that is that's managing this traffic. So let's push 100 requests through here. All right, that takes just a second. And then when we push those requests through, we can take a look at the Z tunnel logs, and you can see these are the access logs from the Z tunnel component itself, and you can see it's managing both outbound and inbound traffic between the various nodes. You can see if you look carefully there, you can see the spiffy IDs for the workload. So basically, because we're using Istio here, all of the workloads have their own cryptographic identities, and we're going to be able to see those here in the logs, as well as be able to build policies based on those, which you'll see in just a few moments. Okay, so indeed we can tell there is traffic. The service worked. There's traffic that's been going back and forth. If you take a look at all right, okay, there we go. If you take a look at if you take a look at the pods here, you can see for all of our workload pods, you can see these pods are all listed as one of one, right? There is no sidecar that's been injected here. It's simply the workloads themselves that are talking to their local Z tunnels, all right? And so now let's take a look at some of the observability. So one of the three pillars of service mesh is observability. At the foundation of observability is metrics, and so we want to show you some of the metrics that we're getting out of this. Even at layer 4, we don't obviously get as rich of metrics as we do with full layer 7, but we get metrics from layer 4 as well. So if you run this command here, it's going to scrape the metrics endpoint of the Z tunnel, and you can see there's obviously not the only metrics you get, but this is basically measuring the number of TCP bytes that are going between various sources and destinations, and you can see those. You can see the different. You can see the source and the destination and the actual byte quantity that's going through there. All right. So we do have some metrics, which is very nice. You can, of course, stream those to your favorite, your favorite aggregation engine and build, dashboards and logs and alerts and all that sort of stuff as well, which is good. But now let's start talking about where a lot of people really get excited about this architecture is from a security standpoint, kind of this simplified infrastructure that still allows you to have some pretty sophisticated security policies. So we're going to do that. We're going to use the Istio authorization policy CR, custom resource, to build that. And we're going to start at the very bottom. We're going to allow nothing, no traffic to pass. We're going to test that out, make sure that works. And then we're going to establish a policy that allows us to basically just green light the path that we want to have activated. So in other words, kind of a least privilege approach where we only allow the services to talk to each other who want to talk to each other. So we don't have these sorts of rogue connections going on that often have unexpected consequences. So we're going to start with a allow nothing policy. So let's establish that. And then what do you expect to happen? So if we establish an allow nothing policy within the mesh, if we try to run the same curl command through the Istio Ingress gateway that we did before, what do you expect to happen? Right, it's going to fail. Right, it's going to be rejected at layer 4, and nothing is going to work. Now, what we're going to do in this next step is we're going to establish a series of authorization policies that activate just the path that we want to allow through this service network. So you can see, you can see the first thing we're going to do is we're going to establish a policy for the web API service. We're going to say we want to allow actions that originate from these two identities. One is from the sleep pod, which is the client pod we've been using, and the other one is the Istio Ingress gateway. So we only want to allow those two services to call the web API. Then we'll have a second policy that's going to activate the recommendation path. Basically, for the recommendation path, we only want to allow calls from the web API to the recommendation service. And then third and finally, for purchase history, we're only going to allow calls that come from recommendation to purchase history. And so we're going to establish that path as being the only service access path that we're going to support. And all of that's going to be implemented for us. Of course, just core Istio values here, but we haven't done anything. We haven't modified the applications at all, right? We haven't even injected a proxy next to that sidecar, right? We're doing all of this in a policy-driven form outside of the applications themselves. And of course, as I'm sure most of you know, if you follow good CI/CD hygiene and use technologies like let's say an Argo or a Flux, something like that, you can take these CRs, you can put them in a Git repo, and you can manage these policies in a declarative fashion. And it's just a really nice, efficient, repeatable mechanism for doing that. And of course, Istio makes all that possible with this declarative policy-based structure. So we've established our 3 authorization policies. And so what do you expect to happen now? If we make that same call that we did before, we're basically going to hit all of the elements of the path that have been activated. And so there we go. It all works just like we expect. And that's good, but you'll also recall that for the web API itself, we only allowed 2 clients. We allowed a client with the sleep identity and a client with the Istio Ingress gateway identity, which is what we did in the previous example. That worked. But if we hit it from some other random pod that's in our cluster, in this case the not sleep pod, then you can see that's going to fail. Just like before, because we didn't explicitly authorize that path. So in terms of establishing zero-trust architectures, this is a really valuable policy-based way of doing that. And as you can see with Istio, you can do this strictly in ambient mode with just these layer 4 proxies without even activating the layer 7 waypoint components. Okay, so let's run a check here. We're at the end of exercise 2, and now we're going to get to some of the layer 7 components. So let's check. All right, I didn't do anything wrong, which is always good. Let me take a breath here. Any questions at this point? Is this making sense? Yeah? Okay. All right. It's always tough when you're new audience. I obviously don't know most of you individually, and so I'm not sure exactly what context you're coming from, but I hope this is able to convey wherever you are on your cloud native journey. I hope this is able to convey some useful information. So, all right. So third exercise, we're going to focus on layer 7 components. So we're going to look at layer 7 authorization policies. We're going to spin up a waypoint proxy. We're going to look at some of the higher level layer 7 metrics that are available. And then we're going to apply a couple of fun policies. I think this is where Istio really starts to get fun. I come from an app dev background. I think this stuff is fun to be able to go into your application network and say, let's inject some evil fault into here and just see what breaks, right? That was actually my first job out of graduate school. I worked on a air traffic control system in the U.S. And that was actually my job, was to build a system that was non-intrusive, where you could just inject random faults into the applications. It was really fun to watch things fall over, but I didn't like thinking about that when I was on the plane actually flying. Anyway, all right, but I digress. Okay, so we're going to talk about fault injection as a policy, and also we'll do a basic traffic shifting example here. Okay, So layer 7 components, here we come. So we're going to, obviously, layer 4 policies are nice, as we've said, for some organizations who are just getting started with Service Mesh and with Istio. Layer 4 is adequate for what you need, and if that's where you are, then by all means adopt just this component. It's very lightweight, very efficient, and it works great. But often we need higher level layer 7 sorts of policies, and so to do that, we can add another component to the architecture here that's going to look something like this. All right, so here's the example we're going to work through. So you'll notice the top half of the diagram and the Istio component at the bottom, that was all there before, right? We had all of that with our layer 4 componentry. And now what we're doing is we want to establish, so we're going to establish a particular layer 7 policy. And the policy we're going to do here as an example is we want to allow GET requests to be accepted by this web API, but anything that's not an HTTP GET, say a post or a put or a delete, we want to reject that, okay? And so we're going to establish a policy to do that. Now to implement that, our implementation has to get a little more complicated because it's obviously we can't satisfy that policy with just layer 4 proxy components. And so what we're going to do is we're going to spin up using the Gateway API. We're going to spin up something called a waypoint proxy, which is the second component of the ambient architecture that's going to serve the web API identity. Now the way waypoints work are that for each component where you want to establish a layer 7 policy, you'll need a separate, at least one instance of a waypoint that supports each one of those identities, each one of those service accounts in Kubernetes. And so we're going to establish that, and so that makes our traffic flow, it basically adds an extra hop to our traffic flow. So before, with layer 7 only, we were going from the client to the Z tunnel, potentially to another Z tunnel, then to the destination service. Now we're going from client to Z tunnel to the waypoint, right, which is where the layer 7 policies are being enforced, back to a Z tunnel on a target node, and then to the service. So that's our new data path that we're going to be employing for this service flow. So the first thing we need to do is we need to establish this waypoint component. Right now, all we're going to do, we're just going to establish some policies around the web API. So all we need to do is to establish a single waypoint for this web API. So you can see we're kind of we're selecting that waypoint there. All right, so let's establish this gateway API, and we'll roll that out. You can manage these just with standard Kubernetes deployment techniques. So if you have a lot of traffic, right, and you want to say spin up multiple instances for redundancy, performance, scalability reasons, you can absolutely do that, and you basically have the control to make that happen. Also, Solo has a set of products called Glue Platform, which is basically a layer on top of Istio that makes it easier to manage a lot of these things for you, especially if you're operating in a more complex multi-cluster environment. Establishing these base Istio policies in that sort of a context where you have multiple clusters or a lot of application teams that need to collaborate, that can get pretty complex from a configuration standpoint. And so definitely talk to Christian or me afterwards if that's something that's of interest to you in understanding how Solo can potentially support you for those kinds of use cases. But we have established now this gateway API. Our web API, our web API waypoint is now stood up. We can in fact take a look at that. And so you can see, right, just like, you can see the name there, Web API Istio Waypoint. So that is up and running and ready to handle our layer 7 policies. All right. So that's all good. So, all right, so now we're going to implement this more sophisticated policy, okay? So what we're going to do here, this is basically going to say for the web API service, we want to allow requests that come in, traffic that comes in from the sleep client as well as from the Istio Ingress gateway, so from the outside world. We want to allow those two sources to come in, but notice this, we're only allowing operations that use the HTTP GET method, right? If it's a post or a put or a delete, we're going to reject that. So that's basically what this authorization policy says. And what the Istio-D, once we apply that policy, what Istio-D is going to do, it's going to take that policy, it's going to translate it into Envoy configuration, and it's going to provide that to the Waypoint proxy. The Waypoint proxy is a full-up layer 7 Envoy proxy, and it's going to implement to enforce that policy on our behalf. So there is our. Hey, it sounds like we're getting close to. We must be getting close to the end here, right? The music's already started. That's good. All right. So. So now, what do we expect to happen? If we invoke this as we did before from our specifically green-lit client pod with a GET request, what do you expect to happen? Right, that's going to work just like it did before. But let's say we try now a delete request, right? What do you think is going to happen? Right, well, it's going to fail. And let's specifically take a look at how it's going to fail. And there we go. So you can see we get back an HTTP 403 forbidden message, which is exactly what we expect. Basically, that means our authorization policy has been activated. It inspected that request. Oh, sorry, I don't allow delete requests to come from the Ingress gateway to that pod. And so as a result, it's going to be rejected. And again, we're doing all of this external to applications in policy-driven form, which is a good thing. All right. Now, we also get, just as we did with layer 4, we get some observability metrics that are associated with this as well, which is, of course, pretty critical. And also with layer 7, we get some higher level metrics. So, for example, here's one. We're just going to take a look at a sample one that people care about. It's like total Istio requests. And you can see, if you look very carefully through here, you can see, here's my Spiffy ID. This is from my sleep client to my, to my web API service. And this is for 403 messages, right? We've gotten 2 403 failures, which is right. I invoked that twice. Within a failure mode, and you can see the second one here is actually for the 200 responses, and we've gotten one of those, which is right. So let's test that out. Let's run another failure case here. Right? So that one fails, and if we recheck the metrics, what you should see, that top metric should have incremented from 2 to 3, and that's exactly what you see right there. Okay. So, observability is working as we expect. All right, now let's do a couple of, I don't know, what I think are more fun policies. So here's one that's going to, let's say you're doing some chaos testing in your application network and you want to be able to, without letting the, application teams know, ha, 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 evil laugh, you want to be able to inject some random delays into the system and see, hey, does this network of microservices actually hold up? And to do that, we're just going to specify a straight Istio policy here using the virtual service API. And so what we're going to do is this is the key part of this configuration right here. For any request that comes in that where there's a header that says this user is named Amy. I don't know why we're picking on Amy. Maybe she violated some policy. Who knows? We're going to pick on Amy, and we're going to say for all of Amy's requests, we're going to add a 5-second delay for 100% of those requests. All right? So that's the policy we're going to apply. That's going to be applied at the waypoint layer, although, again, that's really, at this point, it's just an implementation detail. I don't really, I'm not obviously controlling that directly. The Istio control plane is doing that on my behalf. So we'll apply that policy. And then let's go down here and test this out. So if you take a look at this invocation string, you can see we're specifying the, I keep forgetting, some of you are in the back of the room. There we go. You can see there's the user AMI header is provided there. And so if we invoke that, 5, 4, 3, 2, 1, boom. All right, there we go. So we got our 5-second delay. Let's say that some, I don't know, better user, some user that hasn't been put on the bad list here. So let's say that user Jim accesses this. What do we expect to happen now? Well, it's not going to trigger that same fault injection path, so we're not going to get a delay, and if you watch, it's going to return immediately, okay? So, and that's all being implemented or being enforced at the waypoint that we just spun up. But again, you don't really have to be aware of that. You just need to be aware of the fact that I can now do these sorts of tests without disturbing the applications themselves. Okay. Now, traffic shifting, a very popular thing to do, canary testing. So you want to roll out version 2 of your app. Version 1 is already out there, working well. But with version 2, you want to start it off with limited traffic. And so maybe one of the steps in that process is you want to shift just 10% of the traffic to version 2, while the bulk of the traffic, 90%, goes to version 1. So that's the use case we're going to implement here. Again, we're operating at layer 7, so we need the waypoint proxy in place to do that. And specifically, we're going to implement this policy for the purchase history service. Purchase history is the one we're going to roll out version 2 for, and so that's where we want to apply this policy. So the first thing we're going to do is we're going to deploy version 2 of the purchase history service. That happens pretty quickly. And then, because we're applying, okay, we have a waypoint out there, right? But that waypoint is for the Web API identity, the Web API service account. In this case, what we're doing is we're establishing policies on purchase history, so we need a separate waypoint to enforce layer 7 policies for the purchase history service. And so that's what we're spinning up here with this gateway component, or this gateway API, is we're going to establish a waypoint for this right there for purchase history. So let's establish purchase history there. That'll take just a second to spin up. And then once that's ready, then we can apply authorization policies that are specifically targeted at purchase history. So what you can see here is we're going to allow requests that come in from the recommendation engine, that come through this, that basically match on this Istio, this gateway component, this waypoint proxy that we just established. So we'll tweak that authorization policy just a bit, and then we're going to apply the virtual service here that you can see is going to do the 90-10 traffic split. So 90% is going to the V1 subset. Excuse me. 10% is going to go to the V2 subset. And so we'll add that to our virtual service. Okay. And then we actually need to establish an Istio destination rule that basically identifies, basically associates the subset named V1 with a particular label on the deployment itself. And so, trust me, the deployment's already been labeled V1. The deployments have been labeled V1 and V2. We're simply associating that here. So we will make that association in a destination rule. And now at this point, what we expect to happen is that we'll have our 90-10 traffic split. So if we send 100 requests through the Web API into the purchase history, what we expect to see is that approximately 10 of those are going to go to V2. And that's what this next step is going to measure. So we're going to issue 100 requests, and we're simply going to grep for, hey, is this V2 or V1? And it should come out. It may not be exactly 10, but it'll be pretty close. It was 12. Okay. But over time, it'll average out. It'll be 10%. So that's basically a couple little examples. We showed you some observability metrics. We showed you some fault injection, and showed you some basically disallowing particular HTTP verbs, as well as showing you this traffic shifting rule that we've all done with the help of the waypoint proxy. Okay, that's exercise 3. This last exercise is really short, and we will complete this, and then we will either get you on your way to your post-conference, or I'm sorry, to the closing ceremonies of the conference, or if you'd like to stay around and take the certification exam, Christian and I will be around. We'll be happy to help you in that, although you all look very, very engaged and smart to me, so I don't think it'll be an issue for you. But what I want to do in this last exercise, a little bonus exercise where we're going to talk about how the ambient mode of Istio interoperates seamlessly with the traditional sidecar-based mode. So we have a lot of large financial services, in particular customers at Solo, and those customers do very rigorous security reviews for their any new architectural element like Istio is. And so frequently what happens is they will have they'll have approvals that say like we will operate for this set of applications, we allow you to operate in in sidecar mode. And so when you're introducing something new like ambient mode, that has to go through its own separate rigorous security review. And so what we expect to happen over time is that there's going to be an existing suite of applications out there that operate in traditional sidecar injected mode, and then there'll be newer sets of applications that, when we think this will be the predominant mode going forward, that will operate in ambient mode. And we need those two, right, obviously, to be able to interoperate with one another. And so that's what we're going to show in this very simple exercise. We're going to spin up another application, and we're going to show you how the two modes can interoperate seamlessly. So if you're still following along with me to this point, and I'm really impressed if you are, let's hit the start button here, and we will dive into this. And this will just be a quick exercise. So a lot of you probably know what the HTTP bin service is. It was actually not working well earlier today, but that's okay because we're going to install it in our cluster. Yeah, it's still, the public service is not behaving today, but that doesn't affect us. Basically, it's an application that just lets you test various HTTP operations. So you want to see, I want to apply a GET operation. I want to see what headers are being passed in, what the source IP address was. Maybe I'm doing some transformations along the way, and I want to see how those transformations turned out. That sort of thing. The HTTP bin service is a great little test bed to support those kinds of operations. And so we're going to install in a separate namespace. We're going to install a containerized version of HTTP bin, and so we'll create a namespace for that. Now notice what we're going to do here. We're not going to create this in ambient mode. You can see we're going to label the namespace Istio injection equal enabled. So what that means is we're going to use the traditional sidecar injection mode in order to kind of instrument this service. So we will label that namespace for sidecar injection, and then we're just going to set up a simple, there's nothing to see here, nothing special, just basic service account, service deployment, right? We're going to establish the HTTP bin service in our cluster, and that's all good. And so what's going to happen now, if you take a look at if you take a look at what's happening here, it's actually still spinning up, but you can see, look very carefully there in the ready column, you can see 0 of 2. So what's happening is this is spinning up, right? It's not just the base service. We're actually spinning up an Envoy proxy that's injected as a sidecar with this service as well. So this is indeed traditional Istio mode. There's no ztunnel here. There's no waypoint associated with this particular workload. We are simply injecting a sidecar, and then we're going to show how these two can interoperate. So you can see now, right, everything's in a good running state. We have our sidecar injected, and now what we're going to do is we're going to do an execution from a pod, from our client pod that's in ambient mode here. All right, you can see the sleep pod there. We're going to invoke this HTTP bin service, which is operating in sidecar mode. And when we do that, it's all going to work just fine. And in fact, you can tell it's coming through the mesh. If you look carefully here, you can see these headers returned by HTTP bin. You can see the x-b3 headers, which are injected by Istio. So indeed, it is being processed through the mesh and is interoperating successfully between the two modes. Okay. That is the end of the workshop content. Are there any questions I can answer for you at this point? We're not quite. Just give me one more second. I'm almost done. But any questions at this point? Yeah. Yes. Oh, okay. So the question is about ztunnel and about how it operates like eBPF. So eBPF is one of the optimizations that we can apply, right, via ztunnel. So there's a ton of work in the community going on around using eBPF to optimize these node local operations, like connections between local workloads and the ztunnels. That's one of the places we're working very actively right now. In fact, you can. We even have in fact, I think Christian's presenting that at a conference soon, right? They're doing an eBPF. So yeah, this is something we talk about a lot at Solo. We have courses similar to this on eBPF certifications, that sort of thing. But yeah, we are big believers in eBPF at Solo, and specifically around these kinds of use cases in terms of optimizing these sorts of node local operations at scale in the service mesh. So yeah, really good observation there. Yeah, Christian, go ahead.
Okay, this is better. Yeah, so by default, it's using IP tables, standard IP tables, just as usual. Yep. But there's an actual flag where which you can flip on, and that will enable eBPF. And for example, if you are also using our enterprise-ready version of Ambient Mesh with the Glue product, that's also using eBPF under the hood. That's some kind of enterprise optimization that we have. It's working a bit differently than the upstream eBPF-based solution, but basically they are the same, and the performance benefits are the same. eBPF is really fast for this, but if you just enable it, by default it will use IP tables, just with regular Istio.
Yep. Thank you, Christian, for adding that in. All right, so if we hit the check button here, we should be done. Yeah, we've successfully completed. All right, so I can tell some of you were following along there, so I appreciate that. So if you would like to now, we will be happy to stick around. If any of you are interested in doing the certification component of this, you should be, if you're in this, where is the Solo Academy? Somewhere I have Solo Academy. There it is. So within Solo Academy, right, you should have completed the hands-on lab now. The next step is the certification exam. Again, multiple choice, pretty quick. If you'd like to go through that and get you a little LinkedIn appropriate badge that you can say that you sat through this session and you learned something. So that is that is that. We'll be happy to support you in that. Let me give you one other thing, and then I'll be done. One other thing to offer you as a next step. So if you're like me and you flew here from another place, you may need some reading material on your flight or your train to get home. And so let me get out of the way so you can get the photo there. So if you follow that bit.ly link there, bit.ly/ambient-book, it will give you an electronic copy of this book, which is really excellent. I mean, you can read it on a typical plane ride, and really goes into detail on sort of the genesis of ambient mesh, the architecture, some of the use cases around it, and it's just a really quick, efficient read that will get you spun up on this pretty quickly. So I highly recommend this book, and if you'd like more information about Istio itself, again, feel free to check out Solo Academy, and there's a ton of material there. Additional courses. We run live events, I mean, all the time in European time zone, North America time zone, Asia Pacific time zone, you name it, it's there. And we'd be happy to be a part of your cloud native journey in whatever capacity you'd like to have us. So there are no further questions. I will turn it back over to.
Thank you very much, Jim. Do we have, yes, please? Yes. Thank you very much. Are there really no further questions to the topic? I know for a fact that we don't have any questions from the online audience. So, Jim, thank you very much for being here. It was a pleasure having you at the Craft Conference. I thank all of you that are watching us online and all of our sponsors. For all of you who are here, we have a closing session at the main stage, and we also have some announcements there, so I highly recommend that you go there. For now, that's it. So thank you very much for coming to Craft Conference 2023. There will be more events from the Craft Hub coming up on autumn, so keep your eyes open. There is a lot of opportunities for us to, or for you, or for us to connect and to learn from each other. So thank you very much. I hope to see you very soon.
Thank you all.